Good morning. Welcome to our second webinar in the Fraud, Waste, and Abuse series. My name is Scott Ward, and I am on the National Government team here at Esri. Your presenters today are myself and Juhan Yoon. As I said a moment ago, this is the second webinar of 2018 in a series covering workflow-specific examples of how GIS can combat fraud, waste, and abuse. You can see the future topics listed here. A little bit of background on why this is an important issue. Based on a study from Wall Street Journal in 2013, the payment card industry estimated fuel-related fraud to cost the industry over $500 million, which is likely even higher now with skimmers being more prevalent today. To give you an idea of the scale we're talking about, for a company that operates 100 trucks and has a 1% loss to fraud, it winds up being around $72,000 annually, just for a small company. To name a few federal users implementing GIS technology to identify fuel card fraud includes the USPS, GSA, and others. Now we'll pass it on to Yoon. Yoon is going to walk us through how auditors and investigators can use GIS to easily identify fraudulent activities, starting from a regular data sheet, visualizing data on a map, and using smart mapping to slice and dice the data. Take it away, Yoon.
Good afternoon, everyone. My name is Juhan Yoon, and I'm an Esri solution engineer. Today, I'll be going over a few common ways to identify fuel card fraud that can easily be detected using GIS. So how does gas card fraud look like on a map? Assuming that a company is using a fleet fuel card service and receiving a report on all the transactions on a regular basis, the data will look like a typical spreadsheet that you're seeing right now. It has the location of the vendor, the time, amount, price per gallon, and other details about each transaction. As long as there's a field that contains location data, it can obviously be mapped, whether it's a single line of text that has the entire address or divided into multiple fields in subcategories, or even lat long or military grids. Depending on the type of the vehicle, we can predict a likely route. For trucks, it's usually a lot easier because it has more limitations on which roads it can use, and the travel route is usually preferred to the shortest time compared to the shortest distance. At this point, you can already see that some points are pretty far off the route. However, we also know that it's not efficient or sometimes even possible to investigate each and every transaction just because it's at a distance from the route. So what people usually do is create a threshold. In this example, it's a 10-mile buffer. This means that the investigator or analyst will prioritize cases that are further than 10 miles out. From here, it's a simple spatial query to select just transactions that are outside of that buffer. And you can see those points represented as blue points on the map. And from here, it's really about how you want to slice and dice your data to prioritize the transactions. The common variable is obviously price or amount of the transaction. And you can change the symbology to represent large amounts with large symbols. You can add more variables such as the number of transactions and give it a color scheme from bright to dark to see which vendor has been visited the most. Based on the map that you're seeing right now, you can see that these 2 points are probably a priority, with 12 transactions averaging amount of $788.80. One of the common questions I get after I show this is how long does it actually take to do this on my own? And instead of explaining it, I think it's always better to show it. So I'll replicate this workflow with another data sheet. So here you can see that I have a new Excel data sheet that has the time, date, name of business, location, the amount paid, price per gallon, and who's the card owner, and the fuel type as well. And to map this on ArcGIS Online, all you have to do is open up a new ArcGIS Online map. And simply drag and drop the file. And it automatically generates the add CSV layer. And from here, depending on the data set that you have, you can either use the coordinate system or the address or add it as a table. Right now, we know that this is US data, so I'm going to change it from world to the United States. And make sure that all the fields are actually matching the field that is being used. So ADDR is actually address and streets. And you can see that city and state is automatically matched. Now, if I click on Add Layer, the data is generated on the map. I'll simplify the Symbology and change the base map to see the data a little bit better. So for this scenario, we're going to say that we're using a small or mid-sized truck that is delivering items from Washington, D.C. to New York. To draw the route, you can simply choose directions, point A, and type in the address, 900 Brentwood Road, Washington, D.C. And the destination in New York is 250 North Boundary Road. And from here, like I mentioned before, depending on the vehicle that you're using, you have different options to choose from. Driving time, rural driving distance, rural driving time, trucking time, distance, walking time, and walking distance. Since we're assuming that this is a delivery truck, we're going to use the trucking time, which gives you the shortest time to get from point A to point B. And you can see the results here as it takes 5 hours and 9 minutes, and it's 259 miles. And I'll choose time unspecified. So now that we have the route, I will save this as a layer and name this DC to New York. Okay, so I think it's having a slight of a glitch at the moment. Or did it? Okay, so the route is here. So the route that is created actually has multiple layers in it. So it has the stops and the lines. And these lines represent each turning point. So it's actually parts of the entire route. And the next step is creating a buffer around the route. So if I go to Analysis, Use Proximity, and Create Buffer, I can now say I would like to use the direction lines with the distance of 10 miles. And the different units available are here: yards, feet, nautical miles, kilometers, and meters. And if the attribute actually has a field, you can use that field to buffer it as well. Additional options are whether you want it overlap or dissolved. Like I said, these are multiple parts, so I would like to have those dissolved as in one layer. And the size round and type round as well. And I run the tool. And now you have a 10-mile buffer around the route. So the next step was selecting the points that are outside of this 10-mile buffer. So all I have to do is go back to Analysis, find locations, and derive new locations. As my expression, I will add, I would like to find the gas stations that does not intersect with our 10-mile buffer layer. Now if I run the tool, these blue points are now my points of interest. So I'll turn off the route, the buffer, And from here, like I mentioned, it's all about smart mapping. So how are you going to visualize your points? So I can go to Symbology and change the attribute of how much I paid, and also make that same attribute to show how big it is. So if I choose color and size, for the colors, I would like to use above and below average. So average is $91, and the sizes to be a little bit bigger for the high payments. If I turn on the route back, now you can see that this point here, that is outside of 10-mile buffer, is $140 payment done by Buford. And this route, if you remember, is roughly 240 miles, and this truck usually runs 8 miles per gallon. So somebody shouldn't really be buying more than 30 to 35 gallons. And considering the price, $3 per, it should be around $100, $105. So $145 is a red flag. You can see the other transaction as well, $127, $139, and see which case to begin your investigation. And if you're familiar with or more used to BI tools for this type of workflow, the other option is using Insights for ArcGIS. Insights for ArcGIS is a web-based data analytics application that works with both spatial and non-spatial data. That works with your ArcGIS Online account and data, as well as other data sources. So when you start your ArcGIS Online or Insights for ArcGIS Online, you simply have to bring in your data set like before. And you can start visualizing your data. So for example, if you want to see how much each card owner paid, select the two fields and simply drag and drop. And here we can see that Buford paid the most of $2,345 when the average is actually $2,006. And these charts can be changed dynamically from a summary table that you can get summary, min, max, average. So if we switch to average, see that the gap isn't that big, such as Bo has 86, Buford $83. We'll switch back to sum. And other types such as bubble charts, donuts, and box plots. I'll switch back to a bar chart. And let's also check out the fuel type that they purchase. Fuel type, name, and payment. So depending on the type of variables that you use and the number, you get different options. So at this time, we'll use a tree map. And we can see that Buford and Bo actually purchased gasoline, whereas Cletus and Mater only purchased diesel. And these fields can be changed dynamically as well. So right now it's by gas type, but we can also do it by card user. We can also do link analysis to see like which card user went to which store. So if we choose card name owner and address, we get the link chart option. So if we expand this and look at it, you can see that none of the drivers actually went to the same location. There is no overlap, there is no links from one store to the other related to the card owner. If the data has time series, we can also add time and visualize it. And and each point is a day. So we can see that Buford on July 29th actually made 3 transactions. You can also change this by how much was paid and see that a total amount of $270. I'll switch back to amount. And of course, because we are Esri, we can also map this data dynamically right away. So just like you geo-enrich or geo-enable the data on ArcGIS Online, all you have to do is select the dataset options, enable location, and match the fields like before. We're going to use address. We're going to use the ArcGIS World Geocoding Service. You can see that it matches the address for address field, city for city, state, and postal. We saved it as zip code. We can run the tool. And now by simply dragging and dropping any field, you can now have your data mapped. And just like before, if you want to visualize it by payment, all you have to do is select a field, drag it on top of the map. You can change the symbology by colors. And make the size a little bit bigger as well, so it's easier to identify. So the best part about using Insights is that it's easy to manipulate data, and it's also interactive. So when you click on it, each card shows representing data that is connected to it. If you want to only see one type of data or one attribute, you can also use the filter tool. But a better way to use the tool is using the cross filters. So you can put on a cross filter on each card. And now when you click on an attribute, it only shows the data related to the field that you selected. Turn it off. It's also easy to delete a card just by clicking on it and creating a new card as well. Simple drag and drop. So let's say you want to keep this workflow and apply it to a different data set from a different state or a new data set that you just received. You can save this as a model. I'll name this Model Fraud, Waste, and Abuse. And you can use this for a new data set because every step that you took is recorded. So now, if I get a new data set for the state of California, I add the data and the model. All I have to do is update it to say that we are going to use the new data table. And now all the data sets are automatically generated right away. And here in the link analysis, you can see that some stores are now actually connected. So some people in California actually went to the same location. So sometimes, depending on how much the pay amount is, this could be the store and the card owner is doing fraudulent activities, such as they're putting in personal gas or putting in or reselling gas and getting cash back for that or rebating. And the final part is that, of course, you want to share this information with other people within your organizations or sometimes with externally. And you can easily click on Share Page. And embed this in the iframe or URL so that other people can have the exact same experience. And be on the same page. So that was using two of our applications, ArcGIS Online and Insights, to detect fraudulent activities related to travel cards. And I will give it back to Scott now.
Thank you, everyone. And now we'd like to give you all the opportunity to get your specific questions answered. Is there training material related to this type of workflow?
Yes, so actually there's a Learn ArcGIS page that covers all of our applications with the actual use case. And we have gas card fraud detection as the learning module that you can use for free. It provides the data and a click-by-click instruction on how to replicate the workflow.
Can Insights be used with ArcGIS Pro?
The data set or the data itself can be shared. So if you have feature layers on ArcGIS Online, you can bring that into ArcGIS Pro. The same way that you bring in that data, you can bring that data into Insights for ArcGIS.
Well, that's it for today then. Thank you for everyone attending, and be sure to join us for our next webinar in the series. The link to our webinar series page is listed here. If you have any questions after the webinar, please don't hesitate to reach out to me at sward@esri.com, and I'll get your query or concern pressed on to whoever it needs to go to. Thank you.